In this video, we're going to tackle systems of three linear equations. So I have your problem up there for you. X squared plus 2y plus z equals 4. Yes, I said z. We have three equations, so we have three variables. 3x minus y plus z equals 5 is the second equation. And 2x plus 3y plus 2z equals 7 is equation 3. This time I went ahead and I numbered the equations because I'm going to reference them when I'm working. Now I do need to caution you, be patient with yourself, be patient with the problem, find the patterns, and you will get to your answer. Just be resilient. Okay, so what we're looking for a pattern, just like we did with elimination. We're going to look at one variable at a time and find the easiest to match because we want to start off with elimination. So I need to multiply all three of these equations by something different to get this x to match, so I'm going to move on and look at a different letter. To get y to match here, just a second. Oh, goodness. To get y to match here, the same thing, we'll have to get them to match to 6, multiplying each one by something different. So we're going to look at z. In the equation, two of our z's have a coefficient of 1 and one has a coefficient of 2. In my opinion, this is the best equation to start with. We're going to have to do some subtraction, but that'll be fine. Now, doing the other letters is not wrong. There are many ways to do these problems. This is just the best way that I've found for me. So if you find another way, that's just fine. What I'm going to do, because equation 1 and equation 2 have 1z, I'm going to do those first. So equation 1 and equation 2, I'm going to stack them up together. And 3x minus y plus z equals 5. Now, in order for the z's to cancel out here, one needs to be positive and one needs to be negative. You can multiply the entire bottom equation by -1 and change all of the signs, or you can subtract. But if you're just subtracting, please be careful. So we have x minus 3x, so that is -2x. And then I want to do 2y minus a -1y, so that is 2y plus y, which is 3y. My z's are gone, so I don't have to put anything there. And then finally we want to do 4 minus 5, which is -1. Okay, this is equation 4. You can just stay there for a few minutes. We're going to need it later. Next, I'm going to match two different equations. So I originally matched 1 and 2. So now I need to match either 1 and 3 or 2 and 3. And it does not matter which one you match up. But in order to use equation 3, we need to multiply one of them by a -2. So I'm going to take equation 1 and I'm going to multiply by a -2 so that it matches this 2 and I can add them and eliminate them. So everything in equation 1 multiplied by a -2. That's -2x minus 4y minus 2z equals -8. Every single thing. And we're going to use equation 3. So that is 2x plus 3y plus 2z equals 7. Now, in this case, more than one thing is going to cross out. That doesn't always happen, but in this case, it's going to be okay. So what I mean by that is here, we've matched these 2's also, so that's a 0. And then -4 plus y is -4y plus 3y is -y. My z's eliminate, and that gives me, here we have -1. So already I found out that y equals 1. Notice that in both sets of equations that I've used, I'm eliminating the same variable. You can't eliminate z in this one and then come out over here and only eliminate y. That won't get us where we want to go. So this is a special problem. It doesn't always happen that we have an answer already, but because I do, I'm going to take this answer and I'm going to plug it in the equation that only has two variables. So we're going to plug in y equals 1. Okay, so that is negative 2x plus 3 times 1, and now instead of y, equals negative 1. Negative 2x plus 3 equals negative 1. Subtract your 3. And we find out here that x equals positive 2, because negative 4 divided by negative 2 is positive 2. Now I know y, and I know x. The only thing left to find is z. So to find z, you can use any of the original equations. I'm going to use equation 1 just because it's up there. You know, I don't know. I don't have a reason. Okay, so I'm going to replace x with 2. We know that y is 1, and z is what we're looking for. Okay, this one worked out because z doesn't have a coefficient, so it's going to make this math a little bit easier. 2 plus 2 is 4. People start to freak out here when this happens. Don't worry. 0 is a number. It can be an answer. Now, just like with the 2 variables, with 3 variables, you write your answer in order, x, y, z as a point. So the answer for this problem is 2, 1, 0. I'm going to do another example. I'm hoping I can get it so that I can show you what I'm trying to show you here. Oops. So I have x minus 5y minus z equals 2, x plus 2y plus z equals 3, and oh goodness, x plus y plus z equals 2. Okay, so you have two options here. All of your x coefficients are 1, which is why I said oh goodness, or all of your z coefficients are 1. I like the idea of using z because 1 is negative and 1 is positive, so I don't have to subtract, I can just add. But it doesn't really matter. Just see your pattern, whatever pattern you see, and go with it. So what I'm going to do, I'm going to match equation 1 with equation 2. Maybe, if I could write it down right. Add them up, and we'll see that we lose z, or we eliminate z here. So this is equation 4. I'm going to do the same thing this time with equation 1 and equation 3. Because we can't use the same equations, but 1 is still helpful because of the negative. So I have to use 3 now. So we're going to do x minus 5y minus z equals 2 plus x plus y plus z equals 2. Interesting. That gives me 2x minus 4y equals 4 because, again, our z's eliminate. Again, do not eliminate z in one and then x in the other. You will have to do it again just to eliminate either x or z again. So keep your work short. This is equation 5. Now this is what I was trying to show you. After you pair 2, you'll usually get an equation 4. And then after you pair another 2, you'll usually get another equation. Now what we want to do is pair these two new equations, equation 4 and equation 5. Because we've eliminated z, now they're just a system of equations like the rest of the homework was. And I can see it. I'm hoping you can see it. I'm pretty excited here. It turned out beautifully. If you know, you know, right? What's happening? These 2's, as soon as I subtract them, eliminate. And that's what I'm looking for, because now I have an equation with just y. But like I said, I need you to be very careful because you'll get all of this work done and then make a sign mistake here. -3 minus -4 is really -3 plus 4. So this is y, not -7y. And then 5 minus 4 is 1. So finally, after working most of the problem, we have an answer. And this is what normally happens. We got y. Now that I have y, I can backward substitute and get everything else. So I'm going to plug y into either equation 4 or equation 5. It doesn't really matter. Y goes into, I'm going to say 4 just because. So we have 2x minus 3 times the answer for y, which is 1, equals 5. 2x minus 3 equals 5. Add 3 to both sides. 2x's are 8, so 1x is 4. Almost finished. Looking for that last variable, we're missing z. So pick one of the top equations. Now I'm going to pick one with a positive z, just because. And I'm going to pick equation 3. It doesn't matter which one you choose, just choose one of them. So 3 is x plus y plus z equals 2. And notice that I had to go back to the top equations instead of equation 4 and 5 because the top have z and 4 and 5 don't. And that's the variable that I'm missing. Okay, so 4 plus 1 plus z equals 2. 5 plus z equals 2. Z equals -3. Okay, last step, write your answer, x, y, z. So 4, 1, -3. If you have any questions, go ahead and reach out. Good luck. We'll do matrices in a different video.